Hi everyone, this is Joni Overly, and we're going to do Module 3, Chapter 4, Number Theory, and Chapter 5, Integers. Okay, let's get started. So we're going to explain the divisibility for numbers 2, 4, 5, 6, and 10, and then we will show our work to apply the divisibility rules for 3, 7, 9, and 11. We're going to write yes or no to each problem. Okay, so here we go. So according to the table, 2 is a divisor if the last digit is an even number. So going over these, the 684, the 4 is an even number. So yes, it is going to be. Then we're just going to go straight to the very end because that's all we have to know. That's all we have to look at. The 4 is an even number, so yes, this one is. The 1 is an odd number, so no, it's not going to be. 0 is an even number, and it's going to be. This number will. This next one has a 0 at the end, and it's going to be. Okay, and this one ends in 8, so it's going to be. Okay, so we will put our 2's up there, yes. Very simple, very simple. Okay, so now, moving on to 3. Next, to check whether the 3 is divisibility, next to check whether 3 is a divisor of 684, according to the table. 3 is a divisor if the sum of numbers of the digits is divisible by 3. So basically, we will just add these numbers up. So, the sum of 6 plus 8 plus 4 is 18. So that's going to be divisible by 3. And next, 2064. So 2 plus 0 plus 6 plus 4 is not going to add up to be divisible by 3. So that's not going to be. And then we're going to add our 5 and our 1 and our 0 and our 5 and our 1. And that one is going to be yes, because all those numbers add up to meet for the sum that is divisible by 3. Next, the 6 plus 4 plus 4 plus 4 plus 9 plus 0 is going to be divisible by 3. Because yes, all those numbers equal up to be 27. I'm sorry. All these numbers equal up and are divisible by 3. Okay, so the next one. 5 plus 0 plus 2 plus 5 plus 0 plus 5 plus 2 plus 8 is another one that is going to add up to be divisible by 3. Okay, so with our number 4. So to check whether our number 4 is divisible by 4, we're going to simply check to see if the last 2 digits are divisible by 4. So example, 8 and 4. 84 is divisible by 4. So yes, it's going to be. Next, 6 and 4 is divisible by 4 because 4 divides into 64. So next, 4 cannot be divided into 51 evenly. So that is not going to be divisible by 4. 90 right there is not going to be divisible by 4. And finally, oh, so 4 and 0 is going to be divisible by 4. And then last, 2 and 8, it is also going to be divisible by 4. Okay, so next we're going to look at our 5. And the rule is on our 5, if it ends in 0 or if it ends in 5, because we know how to count by 5s, right? It's 5, 10, 15, 20, 25. So we know right there that those are just going to be, that's just going to be our simple 5 counts. So right here, our number 4 is no. We have a 4 right here ending on this one. It's a no. Our 1 is a no. But look right here, we have a 0 right here. Yes, that is going to be divisible by 5. And right here, this 0, that is also going to be divisible by 5. And our very last one ends in 8, and no, it is not going to be, because it's not a 0 or a 5. That's pretty simple. That was pretty simple. Okay, so we're going to move on to our 6 number. Okay, so if 6 is the divisor in the number, if the number is divisible by 2 or 3, so the last digit off the number of the double. So let's check the table to see which numbers are divisible by both. Okay, so 684, yes, it is both divisible by 2 and 3. 264, no, it is not. This one right here, ending in 51, no, it is not. This one right here, 90, it is, because it is divisible by both 2 and 3. And this one right here, it's not going to be, because it's not divisible by 2 or 3. And lastly, this big number right here, yes, it is going to be divisible by 2 and 3. Okay, so now our number 7. So number 7 is a little tricky. So a number is divisible by 7 if you can take the last digit of the number, double it, and subtract the doubled number from the remainder number. If the result is evenly divisible by 7, then it's a divisible by 7. So that was a little more complicated. So in this example, the only ones that can do that are the middle numbers, the 51,051 and 644,490. These are our only two that can be done like that are divisible by 7. Okay, so here we go. We're at number 8. So for the number 8 to be divisible, the last 3 digits form a number divisible by 8. So only the numbers 2064 and 50250, 528. Okay. So here we go. 9. What do we think about 9? Well, we know 9 and 3. So, yes, we're right. The 9 is just like the 3. So the sum of the digits that are the divisible by 9, then the number is divisible by 9. So for our table, the only ones that are going to be your 684, but basically all we have to do, since we've already done our divisibilities of our 3s, we know that it's going to be the same exact ones that our 3s were. So the other one is 644,490, and then our very last one. So that's our number 9. Okay, so what do we think about our number 10? What do you think the rule is with that? I bet that's pretty simple. I bet that's anything ending in 0. So that's going to be our rule on that. So the only ones in this one are the middle two, 644,490, because it ends in 0, and 200, the 267,6740. Yes, because it ends in 0. Basically, all we have to do is look at our very ending number. That's pretty easy. The 5s and the 10s are really easy, and the 2s. It's just the 7s that get a little tricky. So next we are going to do 11. So now, if a number is divisible by 11, if the digits can be subtracted and then added in alternating patterns from left to right, sum 0 or 11, the number is divisible by 11. So the numbers, the only ones that will do this, and these are the 51,051 and the 644,490. And there you go. All right. So next, we are going to demonstrate how to use the process of 9s to check each of the following answers. So to use casting out 9s, we're going to first replace every number in the calculation by its remainder and then divide it by 9. So based on the divisibility test of 9s, the remainder of the sum of the digits is the same as the remainder of the original number. So let's take a look at problem A. So we have 416, and we're going to calculate the sum up. So 4 plus 1 plus 6 equal 11, remainder 2, and then we are going to do the 7 plus 4 plus 9 plus 0 equals 20, with a remainder of 2. And then we're going to do the 6 plus 9 plus 8 plus 4 plus 4 equals 31, with the remainder of 4. So then we're going to add up all of our remainders. So our 2 plus 2 plus 4 is going to be 8. So we have a remainder of 8. So 8 divided by 9. Okay. So then we have our 1 plus 1 plus 2 plus 7 plus 9 plus 9 equals 20, with a remainder of 2. So we have to add up that 2. So now we're going to take that and we're going to put the correct sum, which is 416 plus 7,490 plus 69,844 equals 77,750. Okay. So now moving on to problem B. So we are going to start with our 8 plus 5 plus 5 plus 0 equals 18, with a remainder of 0. And then we have our 6 plus 8 plus 8 plus 8 equals 30, with our remainder of 3. And then we have our 2 plus 5 plus 2 plus 5 equals 14 with a remainder of 5. And then we have our 6 plus 0 plus 2 plus 9 equals 17 with a remainder of 8. So then we are going to add up all of our remainders. And we have our 0 plus 3 plus 5 plus 8 equal 16 with a remainder of 7. And then we have our, we're going to add our very last, the 2 plus 3 plus 8 plus 9 plus 2 equals 24 with a remainder of 6. Uh-oh, so the correct sum must be, if you add all those up together, it's going to be 23,992. Okay. Next, let's look at our problem C. So we have, it's going to be a little bit different. It's going to be tricky. So we have our, we are going to remember the remainder of 74,678 divided by 9 is 5. Next, we're going to find the remainder of the two figures of the sum of those remainders. So the remainder is 78,362 divided by 9 is 8. The remainder is 8. So the remainder of 3,674 is 9. Divided by 9 is a remainder of 2. So we are just going to take our 8 minus 2 equals 6. And so there is an error in this calculation. The correct calculation is going to be, if we add it up, 74,688. Okay, so finally, let's go to number D. So the remainder of 337 after dividing by 9 is 4. And the remainder of 620 divided by 9 is 8. So the product, 4 times 8 is 32, simple multiplication, which is a remainder of 5 divided by 9. So based on casting out the 9s, there's an error in this calculation. The correct calculation is going to be 337 times 620 equals 208,940. All right, let's move on to the next one. So our slide number 3 says the color rods shown here are 1 centimeter squared and of lengths of 1 centimeter, 2 centimeters, 3 centimeters, 4 centimeters, all the way up to 10. So we say that a rod measures another rod if a n number of the first rods placed end to end are the same length as the given rod. So we're going to demonstrate the parts of A through E. So which rod will measure the 9 rod? Okay, well, let's look at that. So the answers would be all the rods that would be divided by 9 evenly. So that's going to be our 1, 3, and 9. Okay, So when we answer question B, it says, which rods will measure the sixth rod? Okay, well, we know it's going to be our 1, our 2, our 3, and our 6. That's right. Okay. Now, we're going to use parts A and B to show the greatest common divisor of 9 and 6. Okay, so let's look at this. 1, 3, 9, 1, 2, 3, and 6. What do we see that is in both? And it is the highest number of both. Okay, well, there's ones in both of them, yes. Is there a 2 in both of them? No, but there is a 3 in both of them. So we will have that as our 3. That is our greatest common divisor of 9 and 6. All right. So in D, we're going to place the 10 rod and the 8 rod end to end to form 18 train. Which trains will measure the 18 train? So recall that a train is formed when one or more rods are placed end to end. Remember that from the very beginning of our word problem, of what it told us? So the answer would be our 1, 2, 3, 6, 9, and 18. And finally, demonstrate how you might use these colored rods to demonstrate the notion of the greatest common denominator to children. The greatest common denominator of two numbers R and S is the length of the longest train or rod that will measure with the R train and the S train. All right. Okay. So next, in our slide 4, we are just going to demonstrate the least common multiple method to find the least common multiples in part A through in prime power form. So starting with A, we're going to find the least common multiple in 48, 25, and 65. So we're going to start with 48. We 2 divides into 48, leaving 24. And then 2 divides into 24, leaving 12. 2 divides into 6, leaving 3. So we are going to put 48 equals 2 to the 4th power, because we had to use it 4 times. 1, 2, 3, 4 times 3. Okay. So in our next one, 25 is divided by 5, leaving 5. So 25 equals 5 squared. Okay. And 65 is divided by 5, leaving 13. So 5 times 13 equals 65. So therefore, the least common multiple of 48, 25, and 65 is 2 to the 4th power times 3 times 5 squared times 13. Very simple. So in our problem B, we have the least common multiple of 40, 12, 44, and 363. So let's start by doing this again. So we start with 40, and it equals 40 equals 2 to the 3rd power times 5. Next is 12. So we know 2 and 12 is divided by 6, and then 2, 3. So 44 equals 12 equals 2 squared times 3. 2 divided by 44 is 22. Divided by 2 is 11. So 44 equals 2 squared times 11. And 363 divided by 3 is going to be 121. 11 divided by that will get you 11. So the next one is going to be your 363 equals 3 times 11 squared. So therefore, your least common multiple of all of these are going to be 2 to the third times 3 times 5 times 11 squared. And you're going to use now let's take a look at question C. So first, 250 equals 2 times 5 3 times. So 250 equals 2 times 5 3 times. Next, 2 and 28 and 14 divided by 2 and then 7. So this one's going to be 28 equals 2 squared times your 7. So next, 44 divided by 2 is 22 divided by 2 equals 11. 44 equals 2 squared times 11. And 2 and 110 is 55. And 5 is 11. So we have 110 2 times 5 times 11. So let's see if we can find the least common multiple of all of those. So for 250, 28, 44, and 110 is going to be your 2 squared times 5 cubed times 7 times 11. Okay, that was easy enough. Okay, so in our next slide, in a machine, a gear with 48 tech is engaged with gear with 84 teeth, with teeth A and B on the small and large gears, respectively, in contract as shown. So demonstrate how many more revolutions the small gear will have to make before A and B are again in the same position. Okay, so the small gear will have to make more revolution than larger gear before they meet back in the same spot. So we know that. So let's take a look at the calculation to solve the problem. The first step is to find the least common multiple of 48 and 84. So to find the product of the prime in the prime power factorization of 48 and 54 have the larger exponents. So it's going to be 48 equals 2 to the 4th times 3, which equals 84 equals 2 to the 2nd times 3 times 7. So we're going to remember to use the larger exponents to find the least common multiples. And this is going to be your 2 to the 4th, because you have 2 to the 2nd and 2 to the 4th. So the 2 to the 4th is going to be the 1 because it's going to be the larger. So we're going to say 2 to the 4th times 3 times 7 equals 336. So to find out how many more revolution the smaller gear has to make before A and B are again in the same position, simply divide the least common multiple by the number of the teeth in the small gear. So we're going to divide our 336 divided by 48 equals 7. So it takes the smaller gear we'll have 7 more revolutions before A and B are in the same position again. Okay, so next we're going to create a magic square and demonstrate how you decide the numbers and positions of numbers. So we have integers -3, -2, -1, 0, 1, 2, 3, 4, and 5. The integers to be used in the square are given. We're going to find the sum of all the given integers. So the sum of -3 plus -2 plus -1 plus 0 plus 1 plus 2 plus 3 plus 4 plus 5 equals 9. And the sum of each is the same before, therefore 9 divided by 3 is 3. So the magic number is going to be 3. So we're going to plug our numbers in each row and column, and we'll need to equal 3. So let's try the first row. 4 minus 1 plus 0 equals 3. The next row, 5 plus 1 minus 3 equals 3. And now the first 4 plus minus 3 is 2, and then it equals 3. And the next column, -1 plus 1 plus 3 is going to equal 3. And finally, 0 plus 5 minus 2 is going to equal 3. Okay, so that's all we have for you today, folks. I hope you enjoyed this lesson. Thank you.